Welcome back. In this video we're going to look at how to check for the assumptions in a multiple regression model. We're using the sample data called body fat, and it's available off the sample directory in JUMP. So let's go ahead and create our multiple regression model. I'm going to analyze fit model, present body fat as our y. These other variables are our x's. Effect leverage and run. And so what do we want to look for? Our assumptions are that the points are independent of each other, they have equal variance, and that the residuals are normally distributed. And we can look for those assumptions by looking at three different plots. And so one plot is the one that you see here, actual by predicted. This is our prediction line. We want to see the points just distributed around that without points that are way off the line or that show some kind of a pattern. A second one we want to use is this residual by predicted. And in this plot we want to see just a cloud here. We don't want to see a change in the way that the data look as we go, say, from left to right. We don't want to see any kind of a patterns or trends here. And then a third thing we want to do is to check for the idea that the errors are normally distributed and independent. And so we can do that this way. If we go to the red triangle, save columns, and studentize residuals, and when I did that, we just saved it to the data table, studentize residuals. If I select that, do analyze distribution, y, and then from this red triangle, click on normal quantile plot, then this is what we're hoping to see. We want to see it just distributed along this line here, and without veering off and outside of this if we can. And so this looks very well behaved, and that it's satisfying those assumptions. There's two other assumptions that we often look at, and one is for high influence points, and we're going to look for something called Cook's D, and then also for multicollinearity, and we're going to look at the VIF. Let's start with VIF. From the parameter estimates, if we do a right mouse click here, columns, and then VIF, then we can see this column here that's been added. And what we're looking for are points, VIF values that are more than 10. And so we can see in this case, this value is more than 10. And so we would want to look in the correlation table and do a scatter plot perhaps, and look for the values that are highly correlated with abdomen, and decide which value or values that need to be eliminated because they're redundant. And so we would eliminate parameters using really a subject matter knowledge to identify what would be the best parameter to eliminate, and then check to see if the VIF values are less than 10. Last thing to tell you about in this session is for values that are high influence points. And so to do that, we want to look at Cook's D. For Cook's D, we're going to go to this red triangle, save columns, and then Cook's D. Again, it's saved it now to the data table. I come over to Cook's D, select that, analyze distribution, y. We want the Cook's D values to be less than 1. And so you can see right here that the maximum value is less than, say, 0.3. And so that would indicate that we're okay for that. And so those are ways to check assumptions and conditions, high influence points, and also for multicollinearity in a multiple regression model.